session chair, Professor Saleh Hasan Naqib, to come on stage. Professor Saleh Hasan Naqib is a professor of Rajshahi University and now the Vice Chancellor of this university. Please welcome.
Assalamu alaikum and a very good morning to you all. This is the first session of this momentous event, the centennial celebration of Bose Einstein Statistics, a legacy of Dhaka. So this is really an honor to be present in this session and also to get the opportunity to chair this session. I thank the organizers for giving me this opportunity. Actually, we are running a bit late, so without any delay, I would like to invite Professor Partha Ghosh, and he will be talking as the first speaker of this inaugural speech session. And the title is The Story of Bose, Photon Spin and Indistinguishability. Please, let's welcome Professor Partha Ghosh.
Hello, once again. Yeah. So I missed telling you another reminiscence of mine of Professor Bose, which is that he used to use two kinds of ink. One was a bit green and the other one mauve. So one day I asked him, "Sir, where do you buy such ink from?" He said, "I don't buy, I make them in the lab." Okay, so this is the so this is also a kind of reminiscence, something that I learned directly from the great master. Usually, Planck's law and Bose statistics is taught in most universities in the world in a way which has very little to do with the great contribution, the way the great contribution was made by Professor Bose. Very few people read or have read the original paper. So, being his student, he told me many things about it. So, let me now tell you how he looked at this problem. So, here's Planck's formula, which most of you know about. The main point is that it has two factors. The first factor is 8 pi nu squared d nu over c cube, and the next factor. Now, in all earlier derivations, starting from Planck's, all the way, Planck, Debye, Einstein, Pauli, Ehrenfest, they all assumed the first factor to be the number of modes of vibration of electromagnetic waves. And then they thought of some way of deriving the second factor. Now, the first factor is from classical theory. The second factor is from quantum theory. This is what Bose found very difficult to explain to his students here in Dhaka. there was a logical flaw here. He has said it is logically unsatisfactory. So, he gave a derivation of the first factor from quantum theory. And that is the most interesting thing from which a lot of things we use today came. Bose's letter to Einstein, dated 4th June 1924 from here, said, "You will see that I have tried to deduce the coefficient 8 pi nu square over c cube independent of the classical electrodynamics." And that is the main point. So how did he do it? So whenever you want to specify the state of a system in physics, you use phase space. That is, you say, this is the position and that is the momentum. So how do you do it for a photon? So he calculated. It's so simple. So on the left-hand side is the total volume in ordinary space and momentum space. So ordinary space is V. Then if you just take this R, instead of dx, dy, dz, you say r squared d theta d phi. Do it for momentum, you get 4 pi p squared dp. And then he uses the famous relation which Einstein had used earlier, P equals h nu by c. That's the momentum. So just substitute it, and you get the right-hand side. Now the right-hand side has a volume V and a h cube on the numerator. So Planck had already shown that h cube is the irreducible volume. So if you divide by V and h cube, you get 4 pi nu squared d nu by c cube. But this is wrong by a factor of 2. And this is where Bose comes in. First of all, he gets this factor almost right. Secondly, he says, where does this factor 2 come from? H cube. Yeah, this is a predecessor to the uncertainty principle, but that was already done by Planck. When Planck quantized material oscillators, he did this. And Bose is just imitating Planck, but instead of using material oscillators, he is taking photons. No, the uncertainty principle as a principle was stated later. But the germ of it is there in the H cube volume. Okay, so where does this factor come from? Now, I will come to that, but right now, you see, something wonderful has already happened. The first factor now emerges with a totally new meaning. It's no longer the number of modes of electromagnetic vibration in unit volume. It is the number of elementary cells in the phase space of a photon. That's the number density of states of the photon. Now this number is actually fixed because 8 pi nu squared d nu, 8 pi nu squared. So for a fixed nu, this number is fixed. So if you distribute photons in these states, in equilibrium, there will be some having no photon, some having 1 photon, some having 2, etc., etc., etc. So each state is specified by the number of photons there. If you permute the photons, you don't get a new state. Indistinguishability, automatically there. Now, before him, Planck and others used to think of some energy quanta and so on, the abstract things. Here, for the first time, physical particles like photons get indistinguishable. Had it not been for Einstein, this paper would have been simply thrown away as absurd. But Einstein took it up because, I'll come to that story later. Can I finish and then you can ask questions? Yeah, there are so many aspects of it. I cannot go into all the aspects. Now, in the published paper, one finds the hesitant sentence. It seems, however, appropriate to multiply this number once again by 2 in order to take into account the fact of polarization. That's how it appears in the written paper. As you know, this paper was written in English, sent to Einstein, who then translated it into German and had it published in Zeitschrift für Physik. And in that version, this is what appears. This is the English translation of what appears in the German paper. Now, herein hangs a tale. One day, I had gone to visit him, and he was very in an expansive mood and so on. And he said, I'll tell you something, but don't ever divulge it to anybody. Now, I'm going to divulge it to you, and I'll tell you why. In spite of promising that I will not divulge, I am divulging. He said, look, you know, in my derivation, I got this factor 4 pi, not 8 pi. So you see, I proposed that the photon has a spin, and it is either spinning in the direction of the momentum or against the direction of the momentum. That's why you get the factor 2. Then he smiles at me. By the way, he had closed all the doors, windows, everything, and was telling me in great confidence. He said, Budo kete dile. The old man crossed it out. So I was absolutely flabbergasted. And then he tells me, Asha Shon, at a particular polarization ta ki re? Ami particular spin buji, polarization ta ki? Bola, she started smiling, you know, the budo kete dile. So, he had also proposed photon spin in the same paper, crossed out by Einstein. There's no proof of it. We searched the original paper in all Einstein archives. It's missing from everywhere. The covering letter is there, but not the paper. But there is circumstantial evidence. So, in those days, I was so young, I got excited and I said, Sir, but when photon spin was discovered, you could have told Einstein and he would have agreed that you had proposed it. You know what he said? Let me speak in Bengali first. Ke bar koreche tate ki eshe jaya? Beriyeche to. How does it matter who discovered it? The fact is it has been found. He's so happy. This was Bose. Now, you may ask me, I had promised that I will not divulge it to anybody else, but I am divulging it all over the world. Everywhere I go, I talk about this. Why? Here is the reason. Many years afterwards, when I was in the S.N. Bose National Center preparing for his centenary, which was in 1994, we were trying to publish his collected works. Excuse me 1 minute. because he never kept anything very systematically. So we were looking all over the place for some paper he might have published here and there. I was searching through old paper journals in the Indian Association for Cultivation of Science. And suddenly, I found a paper. Experimental proof of the spin of the photon, authors C.V. Raman and S. Bhagavantam. I was absolutely stunned, so I started reading it. Incidentally, as you can see, they had published short versions of it in Nature and so on. Nobody refers to them. When it comes to photon spin, it's somebody in the Western Hemisphere who has done it. Sorry, it was done by Raman and Bhagavantam. And why did they do it? Here is the story. It is well known, derivation of the Planck radiation formula from quantum statistics. Professor S.N. Bose obtained an expression for the number of cells in phase space occupied by the radiation and found himself obliged to multiply it by a numerical factor of 2 in order to derive from it the correct number of possible arrangements of the quantum in unit volume. The paper, as published, did not contain a detailed discussion of the necessity for the introduction of this factor, but we understand from a personal communication from S.N. Bose that he envisaged the possibility of the quantum possessing, besides energy h nu and momentum h nu by c, also an intrinsic angular momentum of plus minus h by 2 pi around an axis parallel to the direction of its spin, motion. The weight factor 2 thus arises from the possibility of the spin of the quantum being right-handed or left-handed, which is helicity, corresponding to the two alternative signs of the angular momentum. There is a fundamental difference between this idea and the well-known result of classical electrodynamics, to which attention was drawn by Poynting and more fully developed by Abraham, that a beam of light may, in certain circumstances, possess angular momentum. Thus, according to the classical field theory, the angular momentum associated with a quantum of energy is not uniquely defined, while, according to the view we are concerned with, that is Professor S.N. Bose's view in this paper, the photon has always an angular momentum having a definite numerical value of a Bohr unit with one or the other of the two possible alternative signs. Then they describe the scattering experiment they did with circularly polarized light and rotating molecules. Then you get three lines, the main line going through, then the Stokes and anti-Stokes lines. And they calculated that if Bose's hypothesis is true, then the ratio of the intensities would be different from the classical case, and they find exactly what would come from photon spin. So that's why it was the first determination of photon spin. And now you know why I am telling you this. It has been there in the public domain since 1931. I don't still know why Professor Bose was so secretive about it to me. Maybe one reason could be that all this was forgotten. We were conversing sometimes in the mid-60s or maybe even later. And all this was just history. People had forgotten about it. And he did not want me to make a song and dance about the fact that again Einstein had let him down in some way. I think that's the only reason I can find why he asked me not to divulge it. But now I'm divulging it with a vengeance because it's there. And whose papers? C.V. Raman and S. Bhagavantam. The first ever experimental determination of photon spin. Okay. So a short paper by an unknown physicist in an unknown university in a far-off British colony contained two new seminal ideas, the idea of indistinguishability of photons, and of course the idea of the photon spin. So the far-reaching consequences of Bose statistics, or you all know it, just let me go over it quickly. Einstein's contribution was that he immediately recognized, you see, he had his own idea of photons going back to 1905. And he said that these photons propagate independently. Immediately, Ehrenfest and others had pointed out, but then in that case, you will never get Planck's law. Because Planck's law requires some kind of something else. You won't get it from independent particles propagating. So when he saw this derivation, he immediately recognized that this is the final justification for my idea of photons. Yes, they're not propagating independently. They have these strange, mysterious correlations, the famous Bose correlations, the quantum correlations. So he said that this should not be only applicable to photons, it should be applicable to material atoms. And he extended Bose's idea to material atoms by introducing one more constant, which is the chemical constant. And then he showed, as you all know, and you will hear more about it later, that it led to the prediction of Bose-Einstein condensates, which were found 75 years later. Then this is also very well known. So now you see, from that first factor, which is the phase space, he got indistinguishability, and he showed that you won't get all the characteristics of the photon from just phase space, that is X and P. No, there's some other degree of freedom, which today we call internal degree of freedom, which is spin. So now we of course know that there are two kinds of particles, one with integral spin, the other with half-odd integral spin, called bosons and fermions, very well known. Then came the idea, first by Landau, that superfluidity and superconductivity also require, if you want to have a theoretical understanding, the only way to understand is to apply Bose statistics. Now, Landau got the Nobel Prize for the theory of superfluidity of liquid helium-4 in 1962, where he clearly mentions Bose's work. 1972, Bardeen, Cooper, and Schrieffer for the theory of superconductivity. They had to first show that the electrons have to pair up into Cooper pair, which is then a boson and which can condensate. Then Cornell, Kettery, and Wieman finally produced the famous Bose-Einstein condensates. They also got the Nobel Prize. And Abrikosov, Ginzburg, and Tony Leggett, they also got their results, basically for their theory of superconductivity and superfluidity. All of them use Bose's statistics. 4 Nobel Prizes to 10 scientists. But the man behind all this, no recognition from the Nobel Committee. Pranam. Thank you.
Thank you so much, Professor Partha Ghosh. Now the floor is open for questions and comments. I think we have something like 10 minutes because the talk was not that long, so we can allow 10 minutes for discussion. Please.
Yes, Parvez.
It's a facetious comment.
Sorry?
It's a
Do you have any microphone there? There is one here, so no, this is fixed here. Maybe I can open it.
Well, that was absolutely splendid as a lecture. You are so fortunate to have worked with a man as great as he was. Just a facetious comment. It's fortunate that we happen to live in 3+1 dimensions. In 2+1, there are fractional statistics, no bosons, no fermions.
Yes.
So we are happy that about that.
Once you have such a brilliant idea, so many facets will open up, obviously, and that is the strength of the idea. But they are special systems, two-dimensional. Any other question?
Thank you for the wonderful talk. Bose spent several years after his famous discovery in Europe. And then when he came back, apparently he had stopped working on theoretical physics. He stopped working on theoretical physics, right? He switched to more experimental stuff. Is it true? Okay. So, do you know anything about what his experience during those 2 years were in Europe?
Almost 86, and I can't blame my ears.
No. Yeah.
Be a little more clear in what you say.
So I was just wondering, do you know anything about those 2 years? What kind of experience Bose had in Europe, and would you say a few words?
Oh, yes, yes. So, Dhaka University gave him this fellowship to travel, to work in Europe, and his first port of call was Paris. Incidentally, the British followed him because he was in touch with the revolutionaries here, and in fact carried money for one of the revolutionaries the British were looking for. And this money was given to, I'm digressing a little, but I think you should know what kind of person he was. His great friend, the linguist, Suniti Kumar Chattopadhyay, gave him this money and said, you must give it to Abuni Mukherjee, a revolutionary in Paris. But I don't want you to get caught. So I'm giving you a letter saying that I need these some special books from Paris for my research. And I'm giving it to you to buy and come back. So Bose carried that letter. But the British went after him. And he was saved by Sylvain-Lévy, the famous French scholar, who gave him a glowing certificate. So the British couldn't do anything. Anyway, so that's part of the... Okay, then he went there. He wanted to work in Madame Curie's lab to learn chemistry. So he had already made good friends with Langevin, he was talking about. And Langevin was a very good, close friend of Madame Curie. You know what I mean. So he gave a letter to Madame Curie introducing Bose. He went there, and this is how Bose has actually written. He says, the lady was seated there in dark black garments, but I could recognize that this was the great lady. And she read the letter and said, you know, you have brought a letter from somebody I cannot say no to. So yes, you will work on my lab, but I have sad experience with Indians working here, in the sense that here we speak only French. So unless you know French very well, you will find it difficult to work here. So go back, and once you have picked up French, you come and work with me. Bose was stunned because, as I have already mentioned, he was absolutely fluent in French. But Bose said, without even asking whether I knew French, she had assumed I didn't. And he said, I didn't want to challenge, I just came out. He went back 6 months later and worked with her in the famous institute which she used to work in. So that's where he learned a lot of techniques in modern radioactive chemistry and so on and so forth. And he came here and he did a lot of work here in chemistry. His classmate, Sir J.C. Ghosh, was the professor of chemistry here, and he would often not be here. So he had told S.N. Bose that when I'm not here, please look after my students. And you will find these stories in the book by Pratul Kumar Rakhit, who was one of the students here, in detail of how much work Bose had done in chemistry. But he would refuse to put his name in any paper. Then, after coming back from Madame Curie, he then approached Maurice de Broglie, the elder brother of Louis de Broglie. He was then setting up the X-ray crystallography lab in an abandoned stable in their princely estate. And Bose worked with him for 6 months, learning how to build X-ray equipment and the basics of X-ray crystallography, which he set up here. One of the first X-ray labs to be set up in India was here, and it was done by S.N. Bose. Then, in the second year, he went to Berlin, and there he met Einstein for the first time. And he also worked with others there. Einstein had made him a member of some colloquium or the other, and he could borrow books from the library. So he had lots of discussions with Einstein. They were mostly all disagreements. Let me not go into those questions. But he's written a letter to a lady whom he met in Paris. The letter is there in some book or the other. Jacqueline, saying that this exciting time now in Berlin. Last week, Schrödinger came and gave a lecture. No, Heisenberg came and gave a lecture. Schrödinger is coming, and so on and so forth. He said, one day, we were returning home, and we were traveling in a train. At some station, Einstein got up, and finding them, he was excitedly speaking to them about the wonders of quantum theory, completely oblivious of the fact that the other passengers were all looking at him at awe. But then Bose makes a statement saying he's very positive about quantum theory, but there is one thing he does not like about it. He thinks it is he is worried about its basic unreasonableness. It's exact words Bose uses in that letter. Anyway, then after that he came back and he spent his time here. And he did a lot of work in chemistry, a lot of theoretical papers here. But of course, nothing can match that first paper.
We are almost over the time limit of 10 minutes. Maybe I will take just a single question, please. Please.
So I have a kind of speculative question. So there is a,
Can you just come forward and say it a bit louder?
so this is a bit of a speculative question, but there is a phenomenon called Froelich condensation, which is an analog of Bose-Einstein condensation in room temperature. So given your personal experiences with Professor Bose, my speculative question is, what do you think he would have felt about the possibility of, what do you think he would have felt about the possibility of Bose-Einstein condensates at room temperature? So the Bose-Einstein condensation requires low temperatures, yes? There is a phenomenon now called Froelich condensation, yeah? So you can get Bose-Einstein-like condensation at room temperature now. So what do you think Bose's, speculatively, what do you think his thoughts on that would have been if someone gave him the possibility?
Again, I can only speculate.
Yeah.
The fact is that there must be some. Basically, Bose-Einstein condensates was a deduction of Einstein using Bose's idea. It was not Bose. So I don't know what Bose would have said, but hearing you, it seems to me that somehow or other in those Froelich cases, it must be possible to show that everything occupies one state. That's all that matters. Incidentally, Ehrenfest had objected to this way of counting because he said, and this is there, I picked this up from Einstein's third paper, where he says that Ehrenfest and others have objected to this kind of counting on the ground that you can apply statistics to independent quantities. But these things, they have strange correlations. So how are you applying statistical mechanics there? Einstein's answer is classic. He said, yes, this is the problem. But this is the only method of counting known which is consistent with Nernst heat theorem. Because log of 1 is 0, no other counting method will ever give you that. And he said, therefore, we have to accept that this is the correct way. Later on, we will try and understand what these mysterious correlations are all about. Of course, nobody knows, even today, what they are, except that they are there.
So thank you for sharing your insights on the history. So I have a historical question. In the actual condensation paper, it was single authored by Einstein. Bose was not included in there. It's extension of Bose's idea, but do you have any insight why Bose was not included in the condensation paper?
No, I don't know, but Bose, there is a manuscript which we got from the Einstein archives where Bose calculates the fluctuation in gases, and he shows that there are two terms, one term showing particle characteristic, the other term showing wave characteristics. So we apply Bose statistics to material atoms, those atoms suddenly acquire wave-like properties. Okay, so there is this one thing, so maybe Einstein had asked him to check, and he had checked.
Let me.
But he did not. You see, this is something which Professor Sudarshan used to say very often. He said, how come that the great master didn't invite his student to participate in these papers?
The reason I asked this question...
And Bose would not go and say, why my name is not there. He was not that kind of person.
No, I understand, but later on I asked a few Nobel laureates, including some of my colleagues at Princeton. They felt that Bose being not part of the condensation paper, although it's called Bose-Einstein condensate, so that probably hurt his recognition for some way. I'm not saying that was a fair thing to do, but that's the impression I gathered firsthand from a number of...
No, but that is not the reason. The reason is Nobel Prize cannot be given posthumously.
No, I'm not saying, I mean, we don't know the actual reason, but I'm saying I gathered some
Yeah, yeah,
statistical
I mean,
significance on the ground. Some people, why they say what was the reason behind. I'm not saying I know that
No,
or
you
they
see,
know that.
I cannot enter the minds of people who award Nobel Prizes. But the fact remains that this one piece of work has led to so many new discoveries. So many of them have been given the
No,
recognition.
I completely agree with you. I'm sharing what I
Okay,
heard
so
from other.
let me just tell you one thing. I have a very good friend, Virendra Singh, who was the director of Tata Institute at one time. So we were discussing this, and he said, you know, Partho, once we had circulated a question to all the faculty members of TIFR to name the physics Nobel laureates of the last 10 years. He said hardly anybody could. But is there any physicist in the world who does not know Bose? So why bother?
Yeah, thank you.
Thank you so much. I think we need to stop now because our speaker will be with us and we can ask as much we want to. I am just compelled to comment on a few things. I'll just take 1 or 2 minutes. The seed of uncertainty principle was in Bose's paper, but I think what he did a very good application of de Broglie hypothesis. That gives you the connection between lambda, p, and Planck's constant.
That was Einstein's idea for the photon.
For the photon. But still, that relation was also there.
That was done by...
Einstein.
No, that was done by de Broglie.
De Broglie, yeah.
But de Broglie was talking about material atoms.
Yeah,
This was talking
but
about photons.
yes, but the same concept was there as well. And the second thing is, whenever we talk about Bose-Einstein condensation, I think I'm giving credit to Einstein because for photons, there's no chemical potential. The chemical potential is zero in Planck's radiation law. Probably Einstein was the first to think about the so-called particles when you need a chemical potential and how that varies with temperature. And that probably led to the Bose-Einstein condensation, how the chemical potential changes value as you lower the temperature. And this is for the students. When we talk about the Bose-Einstein condensation, we often forget the ideal Bose-Einstein condensation is for completely non-interacting system. But every system we have found Bose-Einstein condensation, they are interacting to some extent. So that is, in that respect, is an unresolved issue, how you get condensation where there is absolutely no interaction at all. And the last one, we often talk about the BCS theory, the Bardeen-Cooper-Schrieffer theory, and talk about Bose-Einstein condensation. But if you read the original paper, you really don't see that connection very clearly. The Cooper pairs, I think the best description comes from Bogoliubov quasiparticles. They are kind of a different entity. So when we roughly use the concept of Bose-Einstein condensation to Cooper pairing, we are actually missing certain aspects of superconductivity. For superfluidity, it's okay. More okay, I would say. So with that, we are thanking Professor Partha Ghosh again, and please. So we are moving to the second inaugural speech, and this will be delivered by Professor Parviz Udbhoy, and the title of this talk is Science and Reason in the Age of Unreason. Please, let's welcome Professor Parviz.
Frankly, I would have preferred that Professor Partha Ghosh continue with his speech. I would prefer to listen to him rather than talk myself, but thank you for inviting me. And thank you for allowing me to change my topic which was a technical one, a physics one. I'd rather speak about what is so important, especially today. Yesterday was the elections in the United States, and we saw the triumph of unreason. It's amazing that the most scientifically advanced country in the world should have elected a president who frankly loathes science, who says this climate change, all this is some right-wing, this is some left-wing communist conspiracy, who says these vaccines are there to make us sick, not to prevent sickness. And of course, the fact that he was elected not once but twice by the majority of Americans tells you that the world is sick. This in the most advanced country in the world. It's worse where I am, but I'll come to that later. But look, we must understand as scientists what science is all about. It's not just about discovering why the sky is blue or why there are black holes in the sky or about how electrons move and that's what gives us our cell phones, makes the modern world possible. Sure, of course it's that, but it's much more than that. Science is about truth. Once we start disregarding that essential message, then science loses and we lose. And you can give countless examples of that. Well, they've been looking for supersymmetry at CERN, and supersymmetry is a beautiful idea where you don't have bosons or fermions, but you have them mixing together in a higher symmetry group. And so they're no longer, separate particles, a separate kind of species. They've been looking for that for a long time, and, they're just not around. Or at least, when you can't find something, you say, it's too heavy, we need a still bigger accelerator. And so a few more tens of billions of dollars, and maybe that's a good idea, maybe that's not, but whatever. But look, they did find the Higgs boson, didn't they? Well, we sort of knew that the Higgs boson must be around because there was so much other circumstantial evidence for it. We did know that the standard model, whichever way you look at it, whether you look for weak neutral currents or this or that, wherever you look for it, it seems to be working fine. But we didn't know for sure whether the Higgs boson actually exists. And they could have fudged it. They could have said, and oh yeah, we found it, but in fact they didn't find it. However, they did not do it. They waited until they had sufficient statistics, better than 5 sigma, before they finally announced it. Fermilab could have done it earlier, but they didn't. So there is that meticulousness, there is that insistence upon truth, which is the defining characteristic of good science, true science. Well, of course, climate change is not the kind of science which allows that kind of precision. This is not like calculating G minus 2. It's much more difficult. But here, we have had from within the science community climate change deniers as well. I won't name him, but he runs a grand center in Italy, and there was a conference in Erice where this person was sitting out there in front, and he says, what nonsense this is to talk of climate change. You write down for me a Lagrangian, and then I'll believe what you're saying. Now, of course, you can't write down a Lagrangian for climate change. It's far too complicated, too many degrees of freedom. And so even if you can write it down for the standard model or anything beyond that, beyond the standard model, you can't write it down for this. But within the scientific community, we did have such people. Fortunately, their voices are becoming fewer, and we hopefully will eventually be rid of them. Because the evidence for climate change is there before us. And now that the world's most powerful country is determined to break all environmental laws and take back whatever little concessions it had made in the past, we need to be very fearful of the future. Well, science has had a lot of setbacks, and in spite of that, it has survived and thrived. And as we, as scientists, recognize, it is the future of humankind. But we need to ask ourselves, in which situations can science prosper and thrive, and in which other situations does it wither and die? Look at the example of Shatannath Bose. He was a nobody sitting in a British colony, and yet because of his brilliant work, he gets invited to see the greatest living scientists of his time. And that's a testimony of the value that science puts on truth. Now, here he gets invited over there, and in spite of the slight rebuff that he got from Madame Curie, he still is invited to be a part of her lab. And that's because of the fact that scientists recognize each other and they value each other for their work, not whether they're blue or brown or whatever color of hair they have or no hair or whatever. That's the greatness of it. But that is a fact that's not recognized everywhere. In particular, it is not recognized in my own country. And I say this over here with particular emphasis, lest you go the way that my country has gone. I'm sad to say, I'm very sad to say, that we could never have celebrated Shatandranath Bose had this been a united Pakistan. Fortunately, 50 years ago, you broke away. Good for you. Today, we cannot celebrate Abdul Salam. In fact, there is campaign after campaign to vilify him. There is no institution, no road, nothing to commemorate him. In fact, should you say that Abdul Salam be celebrated in Pakistan, you will be immediately identified as a Qadiani supporter. And very recently, there has been, just 3 months ago, we at Quaid-e-Azam University, let me tell you, I retired from there in 2010, having crossed 60, I had to. But some of our students, they wanted to have a 3-day festschrift for Salam. And as they announced it, they got permission from the university authorities. But when it was announced, the the organization, Tahaffuz-e-Khatm-e-Nabuwat. This is an organization dedicated to the finality of the Holy Prophet. They came to the university, they met with the Vice Chancellor immediately cancelled it. And thereafter they started a campaign of intense vilification that Abdul Salam had in fact stolen the idea of unification, SU2 cross U1, from Sheldon Glashow. And this went on until there's a small organization that I'm associated with called the Black Hole, until we invited experts from around the world, which included Mike Duff, which included people who had worked with Salam, who had been his students, Taisar Shafi in particular, who completely refuted it and showed that these were the mumblings of a disaffected rival, perhaps. Well, the issue didn't go away, but it's certainly gone down quite a bit. Science prospers in those lands where there is openness, there is acceptance of the other, where there is absence of religious prejudice and national prejudice and ideological prejudice as well. I mean, look at Soviet Russia. Soviet Russia did not accept Einstein. It did not accept Darwinian biology, evolution. Instead, it wanted to create its own biology under a quack called Lysenko, who destroyed agriculture in the Soviet Union. They didn't want to accept quantum theory because it was a Jewish invention, and didn't want to accept the theory of relativity either for that same reason. But the truth wins. And so all the great physicists, well, Stalin and post-Stalin, have used quantum mechanics. They've used the theory of relativity, special and general, and they are recognized precisely because of their contributions to physics in mainstream physics. So it is only when science frees itself from these kinds of prejudices, when it accepts that we are all equally endowed and that the only thing to be valued is the truth, it is then that we can hope for progress. I was really very pleased at the remarks made by the chief advisor, Muhammad Yunus. He said we should have a conference like this, not just in the University of Dhaka, but we should have it all over Bangladesh. I said, my goodness, here is the leader of a Muslim country celebrating a scientist who was a Hindu. Unthinkable. How blessed you are. I don't want to take any more of your time, but certainly I'm delighted to be here. I congratulate you for celebrating a man who has been insufficiently celebrated. May he be celebrated more. And thank you again for inviting me.
Thank you so much, Professor Parviz Woodboy. So if there are questions, comments, please.
Thank you for sharing these deep insights. So you're kind of considering how religious dogmatism has taken over the age of reason, at least in the context of your country. So, but on the other hand, historically, it's in the golden age of Islam where the dialectic theology developed, along with, in parallel, the scientific development also happened. And those civilizations, I'm talking about the Middle Ages, they did not, I mean, there was some conflict, but still the science thrives in a heavily Sharia-dominated society. So why do you think, in the current context of religious dogmatism, they're forgetting the lesson of history? Why the state is failing to, I think this is a pathological case in the Islamic history, what you are referring to, but it's only, but I don't see the great ethos or the worldview, if you integrate holistically Islamic civilization, the science only flourished and survived, and more or less. But it's unfortunate to see that in some corner of the Muslim world, they're forgetting the lesson or the existence of how science and prosperity could survive along with Islamic values.
Well, that's an excellent and a very relevant question, and we must go into how science entered Islam and why it exited Islam. So the story goes to the middle of the 9th century, around 850 or so. Before that, there was no science in Islam. It's not there in the Quran. It was not there at the time of the Holy Prophet. It came when Muslims encountered the treasures of Greek civilization. The first stage was the translation of Greek works, those of Pythagoras, of Archimedes, of Plato, of Aristotle, and so forth, into the Arabic language. That work was carried out not by Muslims, but principally by Christians at that time, some Hindus, and then the Muslims acted as translators. That was the beginning of an age of the Muslim Renaissance. It was the Muslim Golden Age. It brought forth scientific heroes, people like Ibn Hisham, the Kitab al-Manazir being one example of that. You had Jabir ibn Hayyan, chemistry, etc. It's a brilliant period. But let's remember that this was basically Greek science entering Muslim civilization.
But the Greeks learned from the Egyptians. They did not get out of the blue. Pyramids are 1,000 years older than the Greeks.
Sure. In fact,
Egyptians, Euclid and Archimedes, they were in Alexandria. They learned from the Greek how they built the pyramids. All the geometry and the science came from the Egyptians, Africans.
Absolutely.
So civilization evolves over time. It's not tied to faith or anything. That's a natural progress. So when the Muslims came up to their civilization, they just upgraded the existing progress of civilization.
I'm not disputing that. I'm saying the history of science goes back at least 6,000 years. It goes back to the time of Babylon, to the ancient Greeks, to the Chinese, to the Hindus. Then it comes to Greece. And then after 1,000 years gap, it comes to the Muslims, who then created new science and passed it on to the Europeans.
Precisely.
What I am saying is that the doors closed at the end of the 13th century. If I ask you to name me one invention that Muslims have made over the last 900 years, I challenge you to do that. There isn't any. They didn't invent electricity.
Electroweak unification, you referred to
There was no new model of cosmology. It was the Ptolemaic model which was taken over. It is no different from the Greek model of astronomy. If you look at the history of science, you'll see that the Muslims were a continuation of the Greeks. And then the Muslims passed it on to the Europeans, the scientific revolution, and so forth. My only point is that when a society is open to new thought, it will progress. Once religious and national prejudice take over, then it's all over. Then you cannot hope to progress.
So it might be we're experiencing a part of the world in a really dark age. It doesn't reflect the holistic contribution of the
It does.
civilization.
It does. It does very much reflect that. I ask you to name me one important Muslim contribution to science and or technology in the last 800 years. Anything in comparison with the major discoveries of science, there is none. Sad.
Yeah, Professor Woodby, why do you call the age, present age, as the age of unreason?
Oh, I think unreason has been around for a long time. It's been around, well, in the European Dark Ages, certainly. That was the extreme of unreason. But now with the growth of postmodernism, I think there's another age of unreason that's coming up. And you see it now in different manifestations, and now you see it in the most advanced country in the world. So it's everywhere around us, and it has different manifestations. We have to fight it.
Dr. Pervez, very good observation about US elections. I live in Washington, D.C. area, by the way. So for me, the reason we confuse truth and fact. Truth is what you believe, and fact is what science says. Trump said in 2019, the coronavirus comes through your stomach, not through your lungs. So drink chlorine, clean your stomach. That's a truth for his people, not a fact. That's how I explain what happened on Tuesday.
Okay, I concede. Okay.
This is not a question, but a comment which was provoked by your talk. Long ago, I went to the 5th Asia Pacific Physics Conference in Kuala Lumpur. And in those days, Kuala Lumpur was finding it difficult to recruit physics teachers from within the country. So they held a special special discussion session at the end of the conference, which was chaired by Professor Yang, C.N. Yang. And after a lot of discussions, this is what I remember Professor Yang saying. He said, yes, I have studied this problem in this entire region, and I found that science and technology will take roots only in those societies who have traditionally valued learning. I'm quoting him, who traditionally valued learning. And therefore, we must find out how Bose did it, and he sat down. So I agree fully with you that traditional value for learning and openness has to be there.
May I add?
This should be the last question.
In response, just one. In response to what Professor Parthagosh said, had the Mughals valued learning as much as they valued beautiful architecture, I think there would never have been the occasion for a two-nation theory to arise, and that Muslims on the subcontinent would have done just as well, perhaps better, than Hindus. But the fact that they did not value learning, they did value poetry and music and beautiful buildings, but they did not make a single university. I wish we could reverse history.
So, Parvez, I'm just going to add one thing to the discussion here, and that is the politicization of religion as opposed to religion as a belief. And I think that distinction probably explains some of the things that we're talking about here. Because when you use religion for political purposes, which is what we're seeing right now in the United States and in Pakistan and other places, then that creates a whole different set of issues. So do you think that?
You are absolutely right, and it is the use of religion in India which is just as worrisome now as in Pakistan, and one hopes that the Indian people will resist that, fight that, and have that clean separation which existed at the time of Jawaharlal Nehru.
Right. And also just to address what you were saying, Zahid was saying before, I think in the days that you were talking about, they were going side by side. There was no conflict because it was not being used for political purposes. But what you see right now is that the only way people like Trump or people in Pakistan and others, the only way they can get anywhere is by using this card. And that actually also goes into what you were saying, because part of what we are seeing in the US has to do with the lack of education. It's not degrees, we're talking about education. And if you don't have education, learning, you don't have that, and that is the problem. And science cannot flourish then.
Okay, thank you.
Thank you so much. This has been very lively session. I will just comment for a minute or two because this is a question which is very close to me and I often think about it. But my point of view is this is extremely complicated. Whenever you try to see or judge the situation from a single point of view, actually you are missing the point. Because there is no single lens that will tell you why this is happening to a particular country, a particular group of people or so. I'll just give you some example. I have been in China just a few months back. It is anything but an open society, anything but. There are many restrictions, but they are the greatest producer of scientific knowledge these days. So scientific knowledge and scientific productivity, if you say that it depends on how open is the society, I don't buy that. The same goes with Iran. Iran, you know, the kind of society the Iranians have, but still in Iran, if you look at the science they are doing much better science compared to many so-called open societies. So the situation, it has many more parameters, and if you try to look it from a certain angle, I'm sure you will miss the whole picture. The same goes for India. In no way we think the present Indian government is very science-centric or progressive or anything like that, but the science and technology in India is making great strides. So there are many other factors we need to think about, and one thing I absolutely agree, traditional societies can do wonders in science if they value knowledge and learning. And in that respect, I agree completely with Professor Partha Ghosh. The main point is whether we value learning and we love learning, creating knowledge. And there's another thing, poetry, architecture, absolutely beautiful and absolutely necessary. We don't need to promote science at the expense of those other avenues. That is another trend which often makes me very anxious, because now we have put science in a certain pedestal, and we have a trend of undervaluing all other sources of knowledge. I don't think that's a healthy trend. So that's my personal view. Thank you very much. This is the last one, and this will be delivered by Professor Ibrahim, and the title of this talk is Hasan Bose, an all-round source of inspiration for us. We welcome Professor Ibrahim.
Thank you, Mr. Chairman. Let me go back a little from a very interesting discourse on history of science and society and science and religion, and confine myself to a very small town which was called Dhaka, spelled differently, Dacca in those days. And when I was a kind of new student in Curzon Hall Physics Department, when Dhaka was still like that. It was 1962. I'm here to emphasize, to be a shadow of what Professor Ghosh said. His gain was our loss, actually. 1962, he was a student of Bose in Calcutta and getting all the benefits from him. And we lost him by that time. And I got only the legends and stories and all kinds of things. In those days, in 1962, in Curzon Hall, it was all Bose at that time. It was all Bose. Furnitures, pictures, laboratories, everything had his touch everywhere. And I am here because perhaps I am one of the last of the Mohicans who saw somebody who saw Bose, second hand. And then there won't be any, perhaps, even in that category. But it was all Bose at that time. He was quite living. Right beside Curzon Hall was his home. It was still standing at that time, a red brick building. Everybody would just point it out, Bose's house. And most of all, our lab assistants, very old ones. We had at least three, Hiralal Da, Ganga Da, and Suresh Da. Because as teenagers, they were with Bose, and they had stories. We could approach them very well. We were friends, actually. They used to run the gossip house in the canteen. I mean, endless butter toasts and gossips. And it is right on the corridor of Curzon Hall. All Bose gossips. Gossips like this, we used to protect Bose's waste paper basket, because he was always calculating, and throwing out. And students were grabbing at it. All the aspirants of PhDs and these and that, they were grabbing at those. This type of legend, I don't know how true they were, but these were the things we used to hear. And one day, Suresh Da, he was in the statistics department, actually. He came up with a big book, wrapped in newspaper. It's only for you, he was whispering in my ear. And in those days, there was no new market. You buy any book in physics, you had to really hunt for it. And he procured one for me. This was Treatise on Heat by Shah Shivastav, the great Meghnad Shah, by the way. Huge book. And he got one for me. That kind of relationships. But then I had more serious kind of sources for me. This was the very beginning, but then about a year or so, I became a kind of a self-styled science journalist, because when I was in college, I started a science journal magazine, which I ran for half a century, actually, Bigyan Samoyiki, which is a monthly paper. And that was the beginning at that time. And I posed like an editor and journalist at that time. And I was one of the first to interview very young Abdus Salam after his famous Dhaka speech. And he was a very young man at that time, very young man. And he used to lecture us in our physics department. And my source of Bose was a great man. We call him Renaissance man of Dhaka, Qazi Mutahhar Hussain. He was still there, very much living in the statistics department. He was called a Renaissance man because he was everything in one. And a great singer, a great philosopher. He was the kind of a pioneer of open thought in Dhaka. And he was a friend of Qazi Nazrul Islam. Whenever poet Nazrul used to come, he used to live with Mutahhar Hussain in Bardhaman House. That was their place. And I took at least 3 interviews of Qazi Mutahhar, which are about many things, but a lot of it was on Bose, because I was curious, and our journal thrived on it. Bose stories. I will mention here 2, which Qazi Sahib also wrote in other magazines also, but I took it out from him. One was about one single day. He was a lecturer in physics department under Bose, perhaps the youngest teacher at that time. He was called in the Bose's room and given a problem to solve. When Qazi failed, he could not do it. And it was lunchtime. And at that time, Bose came over and joined him. Both of them tried it, but they couldn't solve it. Then they took lunch together and tried till the sunset, but still it was not solved. So Bose invited Qazi to go to his house just the next door. And they tried it over the dinner. And they finally declared at around midnight that it is unsolvable because there is something fundamentally wrong with the question. So both of them tried. So this is a kind of relationship. It tells a lot of things about Bose and the youngest teacher of the department. The other story he said, this statistics department, it would not be here except for Bose. Because one day he just declared to me that, Qazi, I will not keep you in physics department. You will have to learn something else, which is statistics. And Qazi was perplexed. What is this proposal? He is not ready for it. You will come with me to Calcutta next time. So he took him to Calcutta, then introduced him to Prashanta Mahalanobish, and said, I have brought a boy. You have to make a statistician out of him. And his very word was, আমি তাকে হাওয়ালা করে দিলাম, প্রশান্ত মহলানবিশের হাওয়ালা করে দিলাম. That's I just put him in the hand of Prashanta Mahalanobish. Prashanta Mahalanobish, by the way, was a great Indian statistician. And when Qazi came back, he was some real great statistician. And his name as a statistician, his reputation as a statistician, and his reputation as a great scholar also. So we are proud of him also, Qazi Mutahhar Hussain, a great student of Satyan Bose. Now let me come to my journalism further. Naturally, we were extremely curious about this man, Bose, but we could never correspond with him because it was a time, 60s, when India was no-go area. No relationship, no postal service, nothing. So we could not, Bose was sitting there in Calcutta, but we could not correspond with him. We could do it only in 1971. And it was right after 1971, one of my teachers, Professor Harun Rashid, was going to Calcutta. He will see Bose, he said. So we discussed about it. I said, sir, I wonder a lot what made him think about it. It was just like this Curzon Hall, even worse than that. It was a desolate place, small place, desolate place. What made him think about it? Well, I will ask this very question to Bose if I see him. And he went, he saw him, and he asked this question. And do you know what is his answer? Well, he just said, আমি তোদের পড়াতাম যে সেখানে, এই পড়াতে গিয়েই তো আমার এটা মনে আসলো। I was teaching you in the class, and it occurred to me when I was in the class that there is something odd with the equation. And that's what Professor Ghosh told us this morning. So Professor Harun Rashid listened it from the Bose himself, by the way. Then came my correspondence. I started a correspondence with him. I could not go, but because I was an editor, so Bose was very much tolerant of me. He used to write patient letters to me. It was really something in my life. But then, so far as the letter correspondence is concerned, the last one was the best and rather remarkable, rather sad also. I received this letter from Bose. It was something like second week of February, 1974. And it was a big envelope. I opened it, and it was from Satyan Bose, clearly written. But Satyan Bose died on 4th of February. I received it after that. And the letter was not dated, and but the Calcutta postmark was there. It was 22nd of January. 22nd of January, postmark Calcutta. It was a long letter, and it was in answer to my last letter, and with my last issue of the magazine, Bigyan Samoyiki. The main excuse for the letter was to appreciate the receipt of the magazine and to appreciate the articles there. But then it was only sideline. He had something to say to us. That was the important thing. And what did he say to us? He suddenly changed his language, changed his tone. By the way, the letter is in the National Museum, Dhaka. I donated it to the National Museum, Dhaka. He suddenly changed his tone and went back to his youth in Dhaka, his life in Dhaka. And by giving advice to the organizers of the magazine, he said that East Bengal, I cannot forget, is so beautiful. It's so beautiful. He particularly mentioned about Chittagong hill tracts. So beautiful. Even people's culture is so great. And he mentioned the Podda Jamuna Meghna basin, the boat ride in Podda, beautifully. And he mentioned the languages of East Bengal, the colloquial languages, so sweet. He loved them. And the research going into the folklore, I think he remembered Dinesh Chandra Sen, who collected Mamansingh Gitika from Mamansingh area, folklores. He loved them. Then he went back to his own life in Dhaka. He said, he didn't talk about physics. He talked about his company in Dhaka. He said we formed a kind of a adda. We used to call it Barajona, the dozen people. And he named particularly 3 persons in it. He named 3 persons in those 12. One was Annoda Shankar Rai, who was a judge in Dhaka. at that time. But again, a literature man, a writer, great friend of Bose in Dhaka. Then he wrote about Purnendu Majumdar, who was the botany professor in Dhaka College. He mentioned him. Then he mentioned Kazi Mutahar. Kazi was our youngest member of the 12. And by then, Kazi has already become a Kazi. I mean, the Renaissance man. Who else? Bose didn't write it, I am saying it. Who else, when giving a lecture on statistics or physics, suddenly burst out into Tagore song? It was Kazi Mutahar. He used to do that again and again. Wonderful man, wonderful man. We cannot forget him, the great man. And Bose remembered him, Kazi Mutahar, his very young colleague in Dhaka University. So he was so full of energy, so full of reminiscence, so full of nostalgia about Dhaka. And he was only weeks away from his death at that time. Perhaps it was his last letter, because 22nd January, he was ill by that time. 22nd of January, he's posting this letter. He wrote it perhaps a few days earlier, and he died on 4th of February. So I'm mentioning this to give credit to the title of our centenary celebration, Legacy of Dhaka. And here I see him totally as our man. Our man. Sometimes I feel very irritated when our students today, they have forgotten him. I have to ask, if I ask 5 students, only one can say who is Shotan Bose. And most irritable thing is when he says he was an Indian scientist. Indian scientist. I cannot tolerate this. Indian scientist. I say he was our scientist. Nowadays, if you call Indian scientist somebody remote in India somewhere, he was our scientist. He was right here. He was the man who gave us a face. And now you don't know him, you don't identify him. You identify him as an Indian scientist. So he was very much a man of Dhaka. He was very much ours. And even after living a long time in his native Calcutta, he could not forget it. That's what his letter shows. Thank you very much.
Thank you very much, sir. If there is any comment or question, please.
Thank you for your insightful comments. I was just curious about Bose building an experimental lab, like he built the X-ray lab and all that. I wonder whether he was also teaching any experimental physics course here, or I'm sure
Actually, I didn't get him as a teacher.
I see.
I got only some.
Right, but did you hear it from others?
I'm not sure, but the legends say he with his own hand made many of the apparatuses.
I see. Wow,
he
that's
got them
amazing.
made.
Yeah.
And took a lot of interest in the development of the department, and in getting famous scientists for Dhaka University. He spent his decades on it. Brought many scientists like Krishnan, for example, to Dhaka. He attracted many people to the department.
I see. Thank you.
কোনো প্রশ্ন না, আমি শুধু বলতে চাচ্ছিলাম আপনাকে যে উনি যে কনস্ট্যান্ট ডেভিয়েশন স্পেকট্রোমিটার উনি নিজে করেছেন, আমরা সেটা দিয়ে এক্সপেরিমেন্ট করেছি, আমরা নিজেরা করেছি। আরও অনেকগুলো জিনিস উনি করিয়েছিলেন। মতিন চৌধুরী স্যার যে এক্স রে দিয়ে যে প্রথম পিএইচডি করলেন, সেটা এই ডিপার্টমেন্টে করা, স্যারের বোস স্যারের করা ইয়ে থেকে করা। He did many things experimentally. He was a great theoretician কিন্তু এক্সপেরিমেন্টালি হি ওয়াজ এ ফ্যান্টাস্টিক ওয়ান। থ্যাংক ইউ।
Well, regarding whether he actually taught experimental physics here, I have this following story to tell you. Unfortunately, I cannot remember the name of this person. I met him the first time I came to Dhaka when I was invited by Professor Shamsher Ali, and he said, "You must meet one of my teachers." By that time, he had gone blind. So when he met me, he was so pleased that I was also a student of Bose and he was a student of Bose. So he told me a story. He was doing his special paper, I think, was on X-rays crystallography. So, and he was working with Professor Kedareshwar Banerjee, another very well-known crystallographer. So the two of them had done some experiment, and Professor Banerjee thought that they had discovered something great. But to be sure, they must go and consult Sutten Bose. So they went, and Sutten Bose said, he had looked at it and said, asked a few questions. He said, "You do the experiment once more in my presence. If you set up whatever you did, call me." So he went and he said, "Shift that thing from there, shift some, give some instructions." And he said, "Run your experiment again." Those special lines didn't appear anymore. So this was the kind of knowledge that he acquired, I think, when he was doing his apprenticeship with Maurice de Broglie in Paris. He really learned. I mean, one thing is I found about him and about people of that age group, his great friend M.N. Saha, whatever they learned so well. I'll tell you another incident. M.N. Saha and S.N. Bose were the first persons to translate Einstein's papers on relativity into English. And that was published by Calcutta University in those days with an introduction by their friend P.C. Maulanovich. Now, sometime in the 1970s, I had gone to attend some conference in Italy where Max Jammer came. You know, the great historian of science and philosopher of science, Max Jammer. So I met him, and when he heard that I was a student of Bose, he said, "Can you do me a favor?" I said, "What?" He said, "I believe Bose and Saha had translated Einstein's papers into English. Later on, Einstein gave them the permission, but provided it was circulated only in India. That was then some British people also translated, which was then become, popular." Huh? That's what I'm saying, yeah. But later on, couple of English people also translated, and that was in circulation in Europe. But Max Jammer said that there was a crucial mistake in the definition of simultaneity. Some German word the Britishers had translated wrongly, so that in the English translation, the definition of simultaneity became wrong, according to Max Jammer. And he said, "Can you go and find out what Bose and Saha had written about this? I don't want the whole book, just if you can send me a copy of that page." I came home, searched, we looked at that paper, took a photograph and mailed it to him. And Max Jammer said, "Yes, they got it right." See, this is the kind of scholarship that such people had. Even German, they learned so well.
Thank you. Thank you.
Okay. Thank you, sir, once again. With this, okay. Oh, okay. Yes, please.
Thank you. Actually, in response of Dr. Jahid Hassan's question, I want to supplement Professor Azizur Rahman that he made a spectrometer and took it with him to Europe. And then he made the X-ray crystallography, X-ray machine also, in which our former Vice Chancellor, Professor Abdul Motin Chaudhary, did his PhD work. And to supplement Professor Ibrahim's about him, his closest person was Hiralal. Many of us during that time, we remember, we used to hear a lot of stories from him about Sotyen Bose. And the name of the student of Professor S.N. Bose was Professor A.K.M. Siddiq. He just passed away in 2018. He was his direct students in masters. And Professor Partho Ghosh was his last PhD student. So these students I have met, and through media, I've seen 3 of his Beara, we called Beara, and they used to talk a lot about Sotyen Bose, and we used to hear about him. Thank you very much.
Thank you, Madam. With this, we conclude this session, and I think it has been very interesting, enlightening, and we learned a lot about the person and his contributions, his personality, and I think it has been very informative for all of us. Thank you very much.
Ladies and gentlemen, please complete your registration. From the registration desk outside the auditorium, and please collect your coupon for lunch and your conference kit. And we will start again from 2:15. To the session 2, and the session chair will be Professor Hilda. Okay, see you after lunch break. Thank you.